Okay, it's 9 o'clock. We'll go ahead and get started. I'm Brian. I'm with LINBIT. I oversee the US operations. On today's webinar, we have Rene, who is one of our core LINSTOR developers. And we have Philipp Reisner, who's our CEO and founder and core developer of DRBD. Do you want to go ahead and present, Phil? Or
yes, thanks. Thanks for the introduction. Then I will start here with the slides and the overview of what you will see today and what is integrated and attached to Nomad. Yeah, so my name is Philipp, and soon also Rene will speak and Rene will do the live demo. So let's get started. Why LINBIT SDS? When is it a good fit? What is it doing? So it is a good fit when you need persistent volumes for containers. So bam, right, here we are. That connects us directly to Nomad and it's not only to Nomad, also to Kubernetes and Docker Swarm. Just looking over the fence, it is also a good fit for virtualization. So we have a very deep integration with OpenStack, CloudStack, OpenEBOLA, XCP-ng, Proxmox. And for all these virtualization platforms, we have their plugins so that you can manage these storage volumes directly out of these workload orchestrators. For what type of applications is it a good fit? It's very good for all kind of transactional workloads. So number one is SQL type databases. Oracle database, Postgres, MariaDB also is a good fit for message queuing systems. And also analytic processing. So that is these data warehouse kind of databases. So there was an example, as example, I have here the DB2 warehouse because it was extensively tested for the DB2 IO pattern, and it came out as the winner in this comparison. So why is it fast? Where do we fit? So we have an in-kernel data path, so that allows us to do various tricks and optimizations that are not possible when the data path is in user space. So we can reduce the number of context switches on certain scenarios. And the name of this data path is DRBD, and I will talk a little bit more about it because I'm connected to this open source project. The other thing is we allocate the volumes in the moment a volume is created. And with that, I mean, we also decide on which machines copies of this volume will be placed. Again, this makes it faster at IO time. It is built on existing components, and one reason, of course, is because we're lazy, but maybe the more relevant reason is that your day two operation teams will work with software components they might already be familiar with, like DRBD, like LVM, like CFS, ZFS, Lux Video, all these parts, right? It's not a huge, big black box where you start learning from zero. And it is very well suited to be used in a hyperconverged way. Why is that? Because it uses very little CPU and memory resources of your servers. So it leaves all these resources to your workloads. And this is in strong contrast to solutions that, we allocate a number of CPU cores to the storage system itself. So with that, you reduce the number of cores available to your workload. Yeah, then, and from a very, very high altitude, what is it doing? So it manages the storage aspects of a few nodes, might be 3, might be 1,000, or anywhere in between. It manages the storage devices in there, and it gives you virtual volumes. It can be used for multiple tenants, and it also supports multiple storage tiers. So you could have HDDs and SSDs as your storage devices. Basically, it replicates data to keep them available in case something fails, in case you have a node failure, in case storage devices fails. Usually you would do two-way replication, maybe three-way replication. It supports also 4, 5, 6, up to 30, but nobody needs 30. So in essence, it manages many small subclusters which do the data replication. It can select the right paths over your network in case there are multiple NICs, and all this can be part of your business contingency plan. Now I will share a few bits about DRBD. That's the data path component. Then I will look into LINSTOR. And after about 10 minutes, I will hand over here to Rene. So when we look at this data path component, when from a very high altitude, it is like a RAID 1 between a local backing block device and initiated, connected to target, and behind this target, there's again real storage devices. And the DRBD driver unifies all that in it, and it gives you a block device on Linux. And this block device can be in primary or secondary role, and it promotes into primary role in the moment you access it. So in the moment the file system is mounted on it, it becomes primary, and that determines the direction of replication. In order to move your workload to the other node, you simply unmount it here. That often involves that you stop the application first. Then this guy becomes secondary. A moment later, you can start everything here. So you switch these roles. It can handle multiple volumes in a consistent way. That's a consistency group. It deals with more than 2 replicas. So it can mirror to one primary, can mirror to multiple secondaries concurrently. And each of those replication links can be synchronous or asynchronous, and you can switch that at runtime even. It also supports diskless nodes. So that means now it acts like a little bit like an iSCSI initiator. So it gives you access to a data volume that's not local to this node. But unlike in the iSCSI case, it can talk to 2 servers, or in DRBD speak, we call them diskful nodes. It can talk to 2 of them concurrently. So that means for a write request, it sends it to both concurrently and gets the acknowledgements back when it's written, and then it acknowledges it to the initiator. So give me a second. I hope my voice is back. For read requests, it does a balancing of these read requests. So it sends one here, one there, one here, one there. So ideally doubling your read bandwidth. And in case something fails, in case one of those storage target nodes goes down, everything continues for the client because it also works with only one of those guys online. If the failed guy comes back online, it's reintegrated automatically. So it doesn't create work for your operations teams. All this data path technology has been in development since 20 years now, constant maintenance and improvement, and learned a lot of bells and whistles, but there is no more time to talk about all this. Now, that was the data path component. Now, how do we orchestrate all that? And that's called LINSTOR. And LINSTOR combines all these storage building blocks of the Linux kernel and creates a software-defined storage out of it. So what that means, you need a number of Linux nodes. And LINSTOR will orchestrate all these building blocks and give you a REST API on top of it. And through that REST API, you can give it requests like, I need a new volume. It should be two-way replicated. That's the size, that's the name. And LINSTOR will figure out which nodes to use. It will use LVM or CFS to create the storage volume of the necessary size and put DRBD on top of it. And on top of that REST API, we have then connectors to various workloads, like the CSI driver for the Kubernetes and the Nomad world, like the Cinder driver for OpenStack, and so on and so on. So I always prefer to explain it by example. So let's say we have a cluster of 6 nodes, and each of the nodes has enough CPU and memory to run workload, so VMs or containers. In this case, it would be containers, and it has built-in storage devices. Now, if we get a request for a new volume over the CSI driver, we already know where the workload will be initially started. So it tries to create one replica on the same node and a second replica somewhere else. So that's like the optimal layout, because it allows us to read local, and that reduces load on the network and give us better read latency. Only for writes, we need to go over the network and write it on both ends. Now, in case something is migrated, let's say this black workload is migrated to a node that doesn't have a replica of the volume, then DRBD will be in this diskless mode and read from the other nodes. We can live migrate the storage to where the workload is. So that happens completely transparent to the workload, so while the workload is doing I/O. And so the process is, it would create here a new volume, give it into DRBD, that would do the replication part. And when that is finished, it will remove the copy here, because our tentative storage policy wanted to have 2 replicas. Yeah, so let's talk a little bit more about the architecture and the objects which with LINSTOR deals. So the main components are the LINSTOR controller and the LINSTOR satellite. The LINSTOR satellite is like a node agent. So it runs on every node that is either a hyperconverged node, a pure compute node, or a pure storage node. It runs everywhere. It is configuration-less and it's stateless. So you install the daemon, you start it, that's it. And then the controller, well, that has state usually. It can use its built-in SQL database, or you can use an external database, or even something strange like custom defined resources in a Kubernetes cluster. yeah, so it's stateful, but still it can move around for purpose of high availability. And it distributes the work between the satellites. So it establishes TCP connections to the satellites and instructs them what to do. And at this point, your takeaway should be that the data path and the control path are really independent. So that means we can update or we can restart the whole LINSTOR system while you have active volumes doing I/O, because LINSTOR is just configuring it. It's not involved in the data path. And yeah, what else? On top, there is the REST API, client library as CLI. So in the demo, Rene will mainly use the CLI. We have the CSI driver, which connects it to Nomad. And we also have a GUI. But I need to add the GUI is for LINBIT customers exclusive. It's not part of the open source projects. Yeah, when we look at the objects which LINSTOR cares about, it knows all the nodes in the cluster. We use the word resource. In the LINSTOR DRBD language, a resource is just a container for volumes. So in most cases, a resource will have only a single volume, but there are also multi-volumes resources possible. It cares about snapshots, storage pools, shared storage pools, and then resource groups. A resource group, that's like the central thing. So a resource group is like a policy how your storage volumes are allocated in the cluster and all their properties, like how many replicas do you want, where should the replicas be placed. So all that goes into this resource group. So the resource group, that's really the central thing, as we see here on the illustration. And then there are properties that control many things, and these properties exists on all the other objects. And aux properties, that's really like custom labels. You can place them on nodes and on other objects and refer to them in the allocation policies we have in the resource group. Yeah, so on this slide, we have this, let's say, user layer stack. So every storage class you create with LINSTOR has something where it can store data. So that might be a ZFS cpool or a LVM volume group, or some more exotic things like Exos is a hardware appliance from Seagate. OpenFlex is a family of hardware appliances from Western Digital. SPDK, yeah, is a user space optimized data path for NVMe drives, and LVM again. So it needs that. Below might be the deduplication or software rate. Above it, you might add encryption, various kinds of caching, NVMe target and initiator. And at the top in such a stack is usually DRBD, but it's optional. So LINSTOR can also create storage resources or storage classes which are not replicated. So DRBD is just a case there. Okay, so here I have an example how these allocation policies can work. So one So I try to express natural language, what you can express in LINSTOR. So you can say, okay, every volume in this storage class should be 3-way replicated, and 2 copies should be in the same or in different chassis, but in the same rack. And the 3rd copy should be in another room, for example. And these aux properties, they're really user-defined. So it's up in your hands if you label racks and rooms, or if you label chassis, or whatever type of label you use. Yeah, LINSTOR can also help you with selecting the right path over the network. I'm not going into too much details here, and will not attach a Q&A session at this point, but now I'm handing over to Rene for the live demo. Rene, are you ready?
Oh yeah, I am. Thanks. So yeah, also welcome from me. So let me share my screen. And let's get to it. So yeah, Phil already told you all the basics. Or give you an overview of what LINSTOR is and what LINSTOR can do. And here is how the LINSTOR looks from the CLI side. So I've already run LINSTOR NL, which is the short form for LINSTOR node list. So it gives you the list of registers nodes or satellites. And so what we see here is we have in my development cluster here, we have 3 nodes, simply called LINSTOR 1, 2, and 3. So yeah, what else a node can have is nodes have storage pools where you actually store your data. And in this cluster here, have actually more than one storage pool. So every node gets a default diskless storage pool, which is representing a diskless resource assignment from DRBD. Then we have here a default store pool, which is the name used for our fallback name. So if there is some operation you need to do and you don't specify the storage pool name by yourself, this will be the fallback name. So that's why I have it here like that. And this here uses a LVM FIC and has a total capacity of 1 GB and a free capacity of 500 megabyte. Just 500 because it also has within an LVM fin pool, which already takes up 500 megabyte. So that's why it is already consuming the half of it. Yeah, here's the fin pool, and we have always 3 of them because each node has its own storage pool. And then last but not least, there is the ZFS pool. So my nodes run on Ubuntu. I think it's a bit harder on CentOS or RHEL-based systems to get ZFS running, but I think it's possible, but it's just harder. So here I'm using Ubuntu, where it already ships ZFS. And yeah, you see here some basic stuff like LVM it does support snapshots, but we don't support because it gets terrible slow as soon as you have more than one snapshot. So we don't encourage our users to even use it because in production it won't really be usable. But but LVM Fin and ZFS support snapshot, and LINSTOR does it. So as Phil told you, we have resource groups. In my development cluster, I have here this default resource group. As always, it's a default object which every cluster will have. Then we have, or I have added an LVM group and a ZFS group. So the LVM group is basically mapped to my default storage pool. You could also add the fin pool here because it's a list, and the ZFS group is using the ZFS storage pool. So let's just create a resource, and for that you can use the command LINSTOR resource group spawn, which will take as argument the resource group name and how we want to name our resource. Like if you needed storage for a virtual machine, let's say Ubuntu virtual machine, and how much space you want to have. In my example, I will rather keep it small because I only have 2 gigabytes on my storage pool. So let's say 1 gig. And now the magic happens behind what we really see. So you get a bunch of output, what LINSTOR is not creating. And LINSTOR will do actually a lot because it will create a resource definition, a volume definition, and 3 resources. So for each node, 1 resource. And you can check the resources afterwards with the LINSTOR resource list command. So you see, we have now a resource Ubuntu virtual machine, and it's two-way two-way replicated. So we have a disk full assignment on LINSTOR 2 and LINSTOR 3, and a tiebreaker for quorum on LINSTOR node. So LINSTOR 1 is diskus. So I can also show you that. So here are my 3 nodes on them. So on the left side, we have LINSTOR 1. And let's clear the screen. And if we check here, ZFS list, there is nothing. And also LFS only shows the fin pool. But if I check on LINSTOR node 2, we indeed have 1 volume here with 1 gigabyte. And so just to show you that on this node, there is actually no storage being used. But you will have a DRBD resource here. And as I said before, it is diskless. And on the other node, it's up to date. So this means it has a disk and the disk is up to date. So in sync with all the other resources. And just to show you what LINSTOR is actually doing for you, it's when we did this spawn, it created the config files on each node for DRBD, created the ZFS backing disk, so this storage here, put metadata for DRBD on it, and initialized it and make it basically working for you. So these are all steps if you would use DRBD without LINSTOR, which you had to do on your own or with a guide to read and type in all the commands, and also make sure that all the config files are in sync on all nodes. And this is all what LINSTOR is doing for you. And there is even more. Like Phil said, with properties or consistency groups. So LINSTOR will handle the logic that it will place resources on, or more likely, or yeah, you can even define your own auto placing groups, but usually it chooses the node with the most available storage. That's all things LINSTOR do for you. And so if you're wondering, oh, typo. So, and the created DRBD resource you can use then under this device name here. So that's what you would give libvirt or any other or MKFS, whatever you want to do with this resource. Then this is what you would give as a block device. So when my sample was now for use it for an Ubuntu virtual machine, but could also create just a let's say 300 megabytes temp file storage, let's call it like that. So, instituted this metric, and now here we see now that it got diskless on LINSTOR 2. And now we could switch over to LINSTOR 2 and create an ext4 storage or file system on dev DRBD and done. And now mount this. So what you will see now is if you do a DRBD ADM status here, we will see that the resource got primary now on LINSTOR 2. And as I said before, it's still diskless here. So you're basically writing to the network and it will be stored on LINSTOR 1 and LINSTOR 3. But you can use it like you would have a disk on LINSTOR node 2. So could now create the file there. Store it, and now let's say unmount. So now it will become a secondary again because it can only be primary on one node at a time. In most cases, there is one case where it can be on primary on two nodes, but that's I won't even mention it. If you ever, it's only used if you use virtual machines for live migration. So, and on the other node, we can now mount the same DRBD resource and see if our file is there, and it is. And it has our content we wrote on the other LINSTOR 2. You also see this that it's basically currently mounted or used on LINSTOR 2 also in the LINSTOR output. And yeah, LINSTOR a lot more. So like it can do snapshots for you. Then there is snapshot shipping or backup shipping now. It's the new version of snapshot shipping. So you can ship resources from one LINSTOR cluster to, for example, S3 or any compatible like MinIO which is free compatible. Or even you can ship a resource from one LINSTOR cluster to another LINSTOR cluster. This also works since last version. Then, yeah, we have, what else do we have? Yeah, snapshot is for doing local snapshots or node local snapshots, which you can roll back, and also kind of clone from. I mean, there's also a clone command where you can clone a resource on the same node. So we can basically rename operation, or this is used on plugins like OpenNebula or CloudStack, where you want to use your base template and clone it to your actual instance you want to give to the user. And yeah, as Phil also mentioned, we also have an UI for that, all of that now. And this looks like this here, just to reload it. So this is the UI of LINSTOR. I think it's also the latest version I show you here. Basically, it's the nicer version of the client command, of the command line client. So you see here we have 3 nodes. We have currently 6 resources. 1 is primary and it's secondary and 5. And how much volumes we have. You can check the nodes here again, what storage pools you have, usage, and then the resource groups. You can also edit the properties here. So these are the properties that get then like in a ration system. So when you set it on a resource group, all the depending or which have the or resources that have the parent of the resource group will get the same properties. This is, for example, useful if you want to set some DRBD options for some resource groups different than others, and or you can just set them on the resource definitions themselves, like here. So, and here are the remotes, which are used for the backup shipping I told you before. So a remote is basically a definition of an Amazon S3 site or an other LINSTOR cluster. And yeah. Back to the client. I'm going to also show you, you have a few things like what can you see on error reporting, like there is the error report list command, where you can check all current error reports, what LINSTOR couldn't do or had a problem. As you see, this is a development cluster, so I have implementation errors and illegal state, which you normally don't or hopefully don't see. It's just because of developing, and you can then even show more detailed things like our famous error report. And this is even from a very old version here. I just don't clean up here that often. And yeah, the LINSTOR client also has an interactive mode. So if you just type it, then it's like a shell, and with auto completion and what else? Yeah. storage pools types might you also interest. So we have, as I showed you, LVM, LVM fin, ZFS and ZFS fin. Then there is Exos, which is, if I remember correctly, from Seagate. I'm right, Phil?
Yes,
Yes.
Exos is a storage enclosure from Seagate.
Yeah. Yeah. Then file, which is more for testing out stuff in LINSTOR. So this uses the, I think, the device mapper for loop files, and so you can create from a file and storage pool you can use in LINSTOR. If you so you don't have to somehow use a full device, a block device like a disk, so you can just try things out. And yeah, then there's OpenFlex, and OpenFlex is, Phil, help me.
That's hardware appliances from Western Digital.
Okay, Western Digital, yeah.
Yeah, and they are NVMe drives attached with 100 gigabit Ethernet.
Yeah. And yeah, then I think Phil mentioned this before. Then we have SBDK and remote SBDK. Yeah, and these are our basic storage pool types. Then we have also this layer stack Phil mentioned, which I think I can show you what kind of layers we have in the resource definitions. Create here, hidden. So you would specify them. I mean, you can either set them on a resource group or on a resource definition. And here are the possible layers, which is NVMe, Bcache as a caching layer, yeah, DRBD, which we use by default. So I didn't specify that in any resource group. So our default layer list is DRBD and storage. Then you have looks for using encryption with LINSTOR, and cache, which is using the device mapper cache devices, as far as I know. Then storage, and yeah, Exos is a bit of a special thing, like OpenFlex, which is, I think, used if you use a storage pool of that type. And write cache is just also the device mapper write cache. Yeah, and some other options. So yeah, I think I already showed all the picture of LINSTOR here. Yeah,
I have a question for you.
Yeah.
What is your favorite interface? You prefer the CLI or you prefer the GUI?
Of course, the CLI.
So it happened to me today that I witnessed myself clicking through the GUI to find the names of some options.
Okay. Yeah.
So with the graphical interface, I haven't messed around with the new one yet that Liang just made. Are you able to? So you essentially just need to have LINSTOR set up on your servers, but are you able to create and deploy new things completely from the graphical interface, or do you still need to fall back to?
I guess we can. Yeah.
Yeah.
Here we are. So
yes, so after installing the software, you could do the node create, starting with the graphical user interface. So you would go through the node create steps in the GUI. You would go through the storage pool create steps. and finally creating the resource group and or multiple resource groups, and then it would be ready to attach it with using the CSI driver to Nomad cluster, for example.
Okay, so good thing we just hired a new documentation specialist to document all these things.
Yes. Yeah. Maybe we need to add. Yeah, the GUI right now is available from our staging repositories, but it reached such a good quality that we will move it over to the production repositories very, very soon.
Yeah, and as you spoke, I just created spawned in the resource groups speech a test resource from the UI. So yeah, it works.
Okay, cool.
Yeah, and you can also add resource groups here. Like
so we have another question that came in. Can LINSTOR take over existing DRBD setups?
Yes, it can. There is I know. Yes, it can, because LINSTOR will always check if a resource or a volume is already there, if it has the same name we expect. So you might need to do a bit of setup to use it, so it's not completely out of the box. We have once a migration script for migrate from our very, very old, how was it called? DRBD Manage was the predecessor of LINSTOR, and we had a migration script from there. So it can be done, but it might need a bit of knowledge. I'm not sure if it's documented anywhere.
Rene, let me attach a few statements to that. So, so there is no mechanism to read the existing DRBD config file and translate that into LINSTOR expressions. So you would need to rebuild the resource in LINSTOR. And then the final step is that you want to attach it to the existing logic volumes or partitions or whatever you replicate, right? And for that part, you need to set one of those many properties on the resource, but with that it is possible. So the answer is all the things are in place. It's a little bit tricky to do.
Is that something that you guys may consider developing an easier path in the forward or moving forward?
Honestly, there's so many other things on the wish lists and roadmaps that that has no priority to create an easier migration path.
Okay, if there's any other questions, feel free to ask them now. If you'd prefer to raise your hand, we can always call on you and unmute your microphone if you want to ask live versus through the chat.
Brian, I saw a raised hand. No, it's must have been wrong. Yeah,
maybe they put it down.
So maybe I'm talking a little bit until a question comes up. So recently there was release 1.0 of WinDRBD, and which is a port of the DRBD technology to Windows. So it runs there as a kernel level driver, and it's compatible with the Linux version. So it allows you to create replication between Linux and Windows, or just within Windows machines. And
yeah, that's been quite a few years in the making. I remember discussing that originally back, I think in 2012 or 2013.
maybe even earlier, I don't know.
Yeah. Well, before that, it was an April Fool's joke. And then it became a reality.
Yeah. Brian, look out in the chat. There is another question.
How does this integrate with Kubernetes, CSI, and storage classes?
Right. Allow me to take it first, and then Rene can jump in if I miss something. So the resource group in LINSTOR, that is one-to-one mapped to storage classes in CSI. Yeah, that means you create a number of resource groups, and one is, I don't know, replicated this way, the other one is replicated on SSD, the other one is not replicated on HDD. And then you have the same storage classes in CSI. Okay, I hope that answers the question. And if not, Marco, write again.
I believe it does. He said thank you, or thanks. Let's see. Can I use this as a non-Linux admin? So installing, I mean, if you follow our tech guides, you should be able to get it set up. Obviously, we sell service and support around those things, so we're more than happy to help you get going and get it up and running and keep it running. I definitely think you need some Linux administration skills, though, or at least a basic understanding to get it going if you want to manage it yourself. And as I said before, we sell this kind of thing. That's how we support the open source, is that we sell service and support around that. So we're more than happy to do it for you if you don't want to do it, but you still want it. Next question, does DRBD support VM snapshots with OpenNebula? Or does LINBIT? I guess it would be LINSTOR.
Rene, do you want to jump in?
Yes, yes, it does. If the QCOW2 format is used. So if you have a virtual machine which has the image type QCOW2, and it is written on the block device, on the DRBD block device, the VM snapshot can be used, yes. I tested this. But as soon as you have a raw type or anything else, no, because libvirt won't let you do that, because libvirt needs some place to store the RAM image or the memory image somewhere. And there is no way or no easy way to tell that, tell how or where to put that. But as a QCOW2 image, this is integrated in the image format, and it writes it somewhere there. There it's possible. And works out of the box with the LINSTOR driver or plugin. And yeah, while I speak about that, we're currently in the process to release a new LINSTOR version. So it will be first in RC, but as soon as this is out and released, there will follow a new OpenNebula plugin version. which use some new stuff for cloning and also revisited code. So it will also no, how to say, you need to have the latest LINSTOR version to work with the new plugin. So just to give that out.
Okay. So we're going to go ahead and wrap this up now. We've got another webinar coming up in 5 minutes. So we're going to give everybody an opportunity to take a break. Thank you all for attending. And I think we'll post this on YouTube if you want to circle back and watch it again. And we'll see you next time. Thanks, guys.
Okay. Thank you. Bye.